Stop the presses. Something extraordinary has just happened in the world of astronomy. The astronomical community has just been rocked by a new release, sending ripples of excitement and confusion through observatories worldwide. The Virtual Telescope project has published the first new images of the interstellar Comet 3I Atlas since it vanished behind the Sun, reigniting a mystery that had been simmering for weeks. This isn't just any comet, it's a rare visitor from another star system carrying secrets from a distant sun and the vast, uncharted regions between the stars. We expected a triumphant, glowing object emerging from its solar passage, dazzling us with its renewed brilliance. But what we got was something else entirely, something no one could have predicted. The news alerts are flying, astronomers are scrambling to their computers, eager to make sense of the unexpected data. This is one of those moments in science you remember. The thrill of the unknown delivered in a single stark image that challenges everything we thought we knew. For weeks, 3I Atlas was hidden from our view, locked in a cosmic dance with our star, its fate uncertain as it disappeared into the blinding solar glare. Now, it has emerged from the glare, and the world has been watching with bated breath. The Virtual Telescope project was the first to get a clean shot, capturing the comet's return in a moment of scientific triumph. And that shot has changed everything we thought we knew about this interstellar wanderer, forcing astronomers to rethink their theories. Before it ducked behind the Sun, 3I Atlas was a spectacle, bright, active, putting on a show for anyone with a telescope. We saw a fuzzy coma, a cloud of gas and dust boiling off its surface, evidence of its dynamic journey through our solar system. It was behaving like a classic comet, albeit from another part of the galaxy, a cosmic performer on a grand stage. The expectation was that after its close pass by the Sun, it would be even more spectacular, perhaps lighting up the night sky with renewed energy. Instead, the curtain has risen on an empty stage, leaving astronomers and skywatchers alike in disbelief. The images are in. The verdict is baffling. The comet's transformation is both dramatic and puzzling. The vibrant, active comet we knew is gone, replaced by something almost unrecognizable. In its place is a ghost, a single solitary point of light, barely distinguishable from the distant stars, haunting the darkness. No fuzz, no glow, no tail. The comet's signature features have vanished, as if erased by the Sun itself. It's as if someone flipped a switch and turned the comet off, leaving only a faint memory of its former glory. This isn't a triumphant return, it's a mystery. The cosmos has thrown us a curveball, and the questions are only beginning. The breaking news isn't what we saw, but what we didn't see. The silence of the comet speaks volumes. In astronomy, sometimes the absence of evidence is the most compelling evidence of all, hinting at hidden processes we have yet to understand. Something profound happened to 3I Atlas while it was hidden in the Sun's glare. Something that stripped it of its brilliance and left only a shadow behind. Now, we're left to grapple with the implications, piecing together clues from the faint traces that remain. The ghost comet has returned, but it's not the comet we remember. Its story is far from over, and the universe has once again reminded us how much we have yet to learn. The new images from the Virtual Telescope project reveal a profound and sudden change in the comet's appearance, something that has left astronomers both fascinated and puzzled. When we last observed 3I Atlas, it displayed a distinct coma, a glowing, ethereal cloud of gas and dust that surrounded its nucleus, making it unmistakably cometary. It was a beautiful, active comet, behaving exactly as we'd expect from such a visitor, with a bright tail and a lively presence in the night sky. Now, the comet is reduced to just a tiny dot, a mere stellar point, almost indistinguishable from the background stars. The fuzzy coma is gone, it has simply vanished, leaving behind no trace of its former glory. This is a dramatic transformation, one that has taken the astronomical community by surprise. Comets are defined by their activity, by the gas and dust they shed as they approach the Sun, creating those iconic tails. To see a comet so active suddenly become so inert is like watching a roaring bonfire instantly turn into a cold, lifeless ember. The change in brightness is staggering, far more dramatic than anyone anticipated. It should have been a bright, extended object. Instead, it is now so faint that only the most powerful telescopes can detect it, making it nearly invisible to the naked eye. The comet has effectively shut down its production of gas and dust, becoming dormant almost overnight. This is our first real evidence of what happened during its perihelion passage, the closest point to the Sun in its orbit. While it was hidden behind the Sun, we were blind, left to guess and speculate about its fate. Would it break apart, or survive, and put on a show? The answer, it turns out, is neither of those extremes. It survived, but only as a shadow of its former self, a faint remnant of what once was. The vibrant, active interstellar visitor is now a quiet, dormant rock, drifting silently through space. The question echoing in every astronomy department is the same. Why did this happen? What changed so suddenly? What happened to 3I Atlas, and what secrets does it still hold for us to discover? To truly grasp just how bizarre 3I Atlas's transformation is, let's compare it to a more familiar visitor. Comet Lemon, one of our local comets that astronomers have studied up close. Comet Lemon also recently passed close to the Sun, enduring the same intense solar heating and radiation that 3I Atlas experienced. But its reaction to this solar encounter was completely different, almost the opposite in fact. When we point our telescopes at Comet Lemon, we see a bright glowing coma, and a beautiful, long tail streaming behind it. It's the classic picture-perfect comet that you might imagine from textbooks or movies. The solar energy it absorbed is powering a spectacular display, lighting up the comet and making it visible even from millions of kilometers away. Gas erupts from its surface, and dust forms that iconic sweeping tail that stretches across the sky. Now, place the image of Comet Lemon next to 3I Atlas, and the difference is immediately obvious. The contrast is stark. One is vibrant and active, bursting with energy, while the other is just a lonely, faint point of light. Both are icy bodies. Both just flew close to the Sun. Both should have reacted in similar ways. Yet one puts on a dazzling show, while the other looks like it's given up, barely reacting at all. This isn't a subtle difference. It's a fundamental, dramatic difference in behavior that astronomers can't ignore. Comet Lemon proves that comets don't just become inactive after passing the Sun, many actually become more active and spectacular. The fact that 3I Atlas is behaving so differently suggests something about it is unique. Is it its composition, something in its chemistry, its structure, its internal makeup, or perhaps its mysterious origin from deep interstellar space? Whatever the reason, 3I Atlas is not playing by our rules, and it's forcing us to rethink what we know about comets. The central puzzle is the dust, or the lack of it. When a comet nears the Sun, its ice sublimates, blasting dust and rock into space. This forms the coma, and, more importantly, the dust tail. For most comets, this trail persists for weeks or months after a solar pass. So, where's the dust from? Far in the freak tree, where's the dust or 3I Atlas? The new images show no evidence of a dust tail. Even if the comet stopped all activity at perihelion, the dust it released should still be there. The fact that we see nothing suggests either there was no dust, or it's behaving in a way we've never seen. It's as if the truck drove by, but the road is perfectly clean behind it. This challenges our understanding of cometary physics. The most straightforward conclusion: our initial assumptions about the comet were wrong. The material it was shedding wasn't the fine, lightweight dust we're used to. Just to deepen the mystery, we have conflicting reports. Before 3I Atlas disappeared into the Sun's glare, it passed close to Mars. Mars orbiters, including China's Tianwen-1 and NASA's MAVEN, were perfectly positioned to observe it. About a month ago, as the comet neared Mars, these orbiters detected clear signs of an active comet. MAVEN picked up hydrogen gas, a sign of water vapor being released. The comet was alive and kicking, spewing gas into space. The Mars orbiters gave us a snapshot of the comet in its prime. This makes its current inactivity even more shocking. The transformation from active to dormant happened frighteningly fast. The data from Mars gives us a firm baseline to measure the shocking change that followed. Let's recap. 3I Atlas was last seen by Mars orbiters as active and bright. It went behind the Sun for a few weeks. When it re-emerged, it was completely changed, quiet, faint, no dust trail. This isn't a minor change, it's a fundamental alteration. The speed of this transformation is perplexing. What could cause a comet to shut down so completely and quickly? 3I Atlas is challenging our assumptions about comets from other stars. The vanishing act isn't just a curiosity, it's a direct challenge to our understanding. Two main theories are emerging to explain 3I Atlas. First, the dust grains might be much larger and denser, more like gravel than powder. Heavy dust wouldn't be pushed into a tail by sunlight, so it would stay close to the nucleus, making the comet appear as a single point. Second, 3I Atlas might be built differently. its core could be more solid than the fragile comets we know. The activity we saw near Mars may have been just a thin, volatile outer layer. Once that layer was gone, a durable, rocky core remained, no longer releasing gas or dust. This suggests some interstellar comets might be more like asteroids with a thin, icy frosting. Both theories paint a picture of an object fundamentally different from our Oort cloud comets. Either would be a major step forward in understanding the diversity of objects in the galaxy. 3I Atlas is rewriting the rules. Why all the fuss about one faint dot? Because it came from another star. 3I Atlas is only the third interstellar object we've ever identified. The first was Oumuamua, the second was Borisov, and now 3I Atlas, each different. These visitors are our only direct samples from other solar systems. By studying them, we learn about planet formation across the galaxy. 3I Atlas, with its strange behavior, suggests the answer to "Are all comets alike?" might be no. The new images are a critical piece of the puzzle. They prove something dramatic and unexpected occurred. Science advances when theories are broken by surprising observations. The strange tale of 3I Atlas is a new chapter in our understanding of the universe. The story of 3I Atlas isn't over. Astronomers will keep watching as it travels away from the sun. Will it wake up again, or is its dormant state permanent? Any new activity would provide crucial clues about its structure and composition. If it remains inert, it supports the Hardy core theory. Meanwhile, scientists will analyze the Mars orbiter data for chemical fingerprints. Was its composition fundamentally different from our comets? The mystery of 3I Atlas is science in action. A surprising observation leading to new questions and theories. We have a visitor from another star refusing to follow our script. The watch continues, and the secrets of another world drift away from our sun.